Hey everybody, how are we doing? Hey everybody, how are we doing? Hey everybody, how are we doing? There you go. I heard an echo right there. I was like scanning everything up. What's up, Emily? We got everything set up. I was updating MuBot. He said he needed yesterday during class. Good to see you, Miranda, Sarah, Bobby. Good to see everyone. Paige. Good to see you all here. Should we do some chapter 6? What should we do today? I gotta move the camera. Oh my gosh. We'll move the camera after class right here. I'm off center. Look at that's the wrong Brian. Can we go to chapter 6? You bet. Good to see you here, Katie. So let's see. Where is my camera? I'll fix it after class. We'll fix it after class. Anyone else? The quiz. Everyone wants the quiz. Let's do the quiz. Let's do this. I need more coffee. Got my veterinary medicine. It's not technically my veterinary medicine mug. Let's do the quiz right here. We are all set up. We are good to go. MuBot is up. Is MuBot not even awake? I had to wake up. Let me wake up MuBot right here. He needed an update, so I went to load up the stream. MuBot needed an update, so I was like, let's update MuBot. He said I would prefer to be updated, and I'm going to load up the MyPearson as we start right here, so we can talk about some chapter 6. And MuBot is awake. MuBot. Who wants points? Not that I'm saying that. He was talking slowly before. Is he appearing? Yes. Woohoo! Let's add some points here. We can probably get to some chapter 7. So let's see here. Probably get to some chapter 7. Let's do that. MuBot's going to help us out here. MuBot's going to move the camera for us, I believe. So here, let me see. Okay. Yeah, a little bit. Oh, stop. Perfect. 100%. Wow. MuBot. Well, that is awesome. The camera is now perfect. It's no longer, it's hard to move the camera by myself, but we have help. So that is really awesome. We are good to go. Getting chapter 6 pulled up. So see, you think MuBot doesn't exist, but the truth is MuBot does exist. So let's go to chapter 6 quiz. And chapter 6 quiz. See, now MuBot's faster. MuBot has been updated and can move the camera for us. Okay, I am pulling up chapter 6 as we speak. Here we go. And chapter 6 is up in my background. Let's bring it over to everyone over here. And let's do this. Let's go jump over to chapter 6 right here. Okay, we are here on chapter 6. Only 13 questions, not so bad. What are the conditions for correlation? What are the conditions for correlation? We should know instantaneously the conditions for correlation. When I look at a question like this, I start to think over like, what are we trying to learn? And this one is just the conditions. So I need to know the conditions because it makes the answer to this question really obvious. So maybe we can zoom in on this. Yeah, you can zoom in on that plot. And the conditions for correlation are going to be really obvious on why this would be a bad idea right here. What are the conditions? So if you're in my class, you should know our saying, something, day enough, no, something. So this is the practice right here. So if you watch my videos, I also shout it out. So you should know the conditions for correlation. Well, that's one of them. You are correct, no outliers. Emily's right. The problem with this one is it's not linear. And does anyone know the full one? Q, straight enough, no outliers, Kayla. Yes, you're in 320, right, Kayla? And so Kayla remembers like, boom, instant. Oh no, Kayla, are you in? Katie, great job too, Katie. Let's throw some 20 more points. U-shaped data. Yeah, Bailey. I think that's in this one. We will get to that. You bet. Let's find that one next here for Bailey. So we're gonna find that one next. So what does QQ mean? QQ means it's so hard when I like can't see people. I'm like, I see you in the 320 chat. I see you. Like I'm like, because usually you can see a student be like, oh, you're in this class, and I see you because I actually see them. But nowadays it's like I see your name. So we have right here. Thank you so much everyone for showing up. This is really good practice, even for 320, doing correlation, which you're doing right now, and regression, which you'll do next week. And then we'll do a lot more regression. So 2 quantitative variables is what QQ stands for. If you have a scatter plot, you do have 2 quantitative variables. Straight enough means a straight line would go through this. There's definitely not a straight line going through this. 2 seconds. Just need to fix one thing. There we go. And so a straight line would not go through this. There's really not outliers here. They're all about equal distance. So the scatter plot is not linear. So reason being is these are not really far away from the form of the relationship. It's just that a straight line does not go through this. If there were outliers, I'm trying to think if we have any plots open today with outliers. This one's a very good plot right here. This is what you want to see. This is two quantitative variables. The relationship is straight enough, and outliers would be points that are far away. So this one now has issues of outliers. Now it's a very good regression. Like this is a very, very good regression. We'd be lucky to see a regression that awesome. Let's find the one with the U-shape. The U-shape one. I don't think it's that one. That one's tricky. We'll come back to that one. Here we go. Is this one you were asking about, Bailey? Is this the one with the U-shape right here? This one can be a little tricky, and we can identify some really kind of easy ones to point out right here first. So which one of these is the strongest, most negative? A, B, C, or D? Which one of these is the strongest, most negative? So go for the strongest, most negative. And correlation has strength between -1 to 1. That's the strength of correlation between -1 to 1. And so when something is stronger, it'll be closer to either -1 or 1. 0 is the weakest in the middle. So which one of these is the strongest, most negative? Emily, you are right. It is C. So we're going to go to C, and we're going to enter in the strongest, most negative right here. That's the strongest, most negative. Now, which one of these is the strongest positive? Which one of these is the strongest positive? The strongest positive will be what? The strongest positive correlation on this screen right now is which graphic? The strongest positive. And the strongest positive numerically is 0.77. So the strongest positive, which mathematically is 0.77, that's closest to 1, or 0 is the weakest, and -1, 1. Nice job, Kayla, right there. Excellent work. That's the strongest positive. And then we have here, and there might be another one that Bailey was asking about. I'll do the other one that has a U shape. So now we're between A and D. So we have left -0.487, which is a moderate weak correlation. I mean, moderate weak, moderate negative correlation because it has a negative sign. And that one goes downward. If you put a line through it, that one goes down. It's weaker though. This one that has a U shape, here's a question. Is this associated? Do these points have an association? Yes or no? Do these points have an association? Like I see a parabola, hint, 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 hint. I see a parabola. Do these points have an association? An association just means, as we know in 320, if you know X, it tells you something about Y. Like if I knew X was right here, would it give me information about Y? They are very associated, but they don't have a linear correlation. Great job, Kayla, right there. They are associated, but they don't have a linear correlation. So when you look at D, it actually has the weakest linear correlation. So there is very, like if you put a line through this, it'd be a flat line. So we can just go here and draw a line. And if you put a line through it, you would have a very, I can't even see it. You'd have a flat line going through it because there's no real good linear correlation for it. That's a nonlinear parabolic correlation. Remember, the forms are linear or nonlinear. And in nonlinear for 320, we have monotonic, non-monotonic. So Kayla, is that monotonic or non-monotonic? You can type mono or non, but is that monotonic or non-monotonic? So let me tell 201 what monotonic and non-monotonic means. Monotonic means one direction, your favorite band. So we're just asking, does this go in one direction or multiple directions? I almost said what the answer it is. So is that non-monotonic or monotonic? This plot right here, which you don't have to know that for 201, but it's really good practice for 320 to look at that and go, that's a something relationship, either monotonic or non-monotonic relationship. So it's non-monotonic, yep, because it goes up and then it goes down. So these all, like the lines are all monotonic because a line has to go in one direction, but the parabola goes in two directions. It goes up and then it goes down, so it's non-monotonic. Great job right there, Bobby, and this is great practice. That's a second part of form. So we talk about strength, direction, form, and unusual features. And this is the way we talk about correlation, which is a bivariate display of quantitative data. So really good practice, even for 320, some practice right there with mentioning the form of something. There's another, well, we can do this one really quickly. We have here the U-shape. And then we can do more chapters. We have here a super strong -1. So the super strong -1, same number. A moderate positive. And this is a moderate weak. There we go. I think I typed them all. If you make a small typo, just tell me. Like I was worried I'd make a typo there. That's so similar to the last one. Oh, that one's a tough one, number 6, or at least theoretically, it's a little bit interesting. This one, I've seen people questioning about this one right here. This one can be a little tricky. Hopefully, let's see if I get it right. So with this one right here, we want to know if any of these have no association. So no association, what does no association look like? Just think about I think about a paint splatter when I think about no association. Your classic view of no association, the classic way to draw no association at all, just complete and utter what? No association should look completely and utterly what? How should no association look? If there's no association, it should look very, very what? I'll wake everyone up here. If there's boom, Kayla knows what we're talking about. Yep. It should look completely and utterly random. So none of these here look completely and utterly random. So I see a a second order, there's a little bit of parabolic relationship right there. That's positive linear. That's very strong negative linear. So none of them show no association. Which scatter plot shows a negative? Well, it just has to go down. So that's only 3. Which scatter plot shows a linear? Now this one right here has a little bit of a change in strength, which we would call heteroscedasticity in 320. In 201, we're going to say the plot thickens here, like it's pretty thin, then it gets thick, then it gets a little thinner. There's limited points, so we might say, do we have strong evidence of heteroscedasticity? No, but there is some concern. We always use as many words as we can in statistics. We like to talk. And so, but the question's only which one is linear, so that's a line. That goes up. It doesn't matter that goes further out. A line still goes through the center of the data. And that's all we're talking about with linear. When you look at linear, you're just asking, if you put a line through the data, does the line kind of constantly go through the middle of the data? And if you notice, there's only really problems with the first one. The linear relationship is fine for the other ones, even if there's, on the second one, a change in strength. If it's weaker maybe, but it's still linear. A line still goes through it. So we should put down 2 and 3 show linear relationships. Which scatter plot shows a weak or moderately strong? This is the scary one. These are the scary ones right here. This is strong. And right now, I might need some help, everyone. I'm between, I think 2, because the last one's going to say which scatter plot shows a very, and just blur out this word in your brain. It just says which scatter plot shows a very strong association. That's going to be 3. And here's where we could get one wrong. If we get one wrong, it's going to be this one. Please tell me if you get something wrong, small like this, I'll probably change it. You can email and be like, hey, Brian, I got a decimal wrong. There are some stuff with the T statistics where decimal accuracy is very important, but let's go ahead and check answer. We got it right. I've gotten that one wrong in the past. And I think they changed the wording on it years ago because it used to be a little bit more confusing. But when we think about, and I just which scatter plot shows a weak or moderately strong. So they're basically asking that. They're asking all the way to weak, all the way up to what they would say is very strong. So they have 3 real asks when you look at this question. They have no association, and let's draw some plots for that. Your only plot of no association is this. This is the only thing of no association. And when you look at weak or moderate, weak linear is going to look something like this would be a weak linear relationship, and this is a weak nonlinear. We can draw a parabola. Now, the weaker something is, the more what there is. This is a good review. The weaker something is, the more what there is. Here's the moderate relationships. And you can see when I do moderate, I'm going to do this right here. It's kind of moderate strong. When I go to moderate, I'm changing something about this. So we have up top weak, and then we have on bottom moderate. And then if I go down here even further and do a strong relationship, and the first one's linear, and the second one's nonlinear. If I go to strong, what am I changing about these plots right here when I go from weak up top to moderate to strong? And you can have nonlinear ones. This is just a stronger, that's very strong. What is changing about these plots as we go from the very top one that is weak to moderate to strong? So you've got here weak. Here, let's put it in a different color. So you got weak, moderate, strong. And these words are subjective, but the closeness of the points, Lauren, you are correct. The what we call it is the vertical scatter, but don't worry, that's the thing about this. Like, I know the statty ways to talk about it, and if I say to people these things, they might be like, "What do you mean by the vertical scatter?" And someone's like, "Oh, the closeness of the points are." Oh, yeah, those points are a lot closer. That makes more sense. That's a better way of saying it. So you are correct. The closeness of the points, the tighter they are around the form. So you can see right here, if we were to do like bands, usually this is the way I always had to draw it. As you draw these bands, and you can see the bands getting tighter around the form. The form for this one is parabolic, and the form for this one here is linear, and it gets tighter around the bands. So the stronger it is, the closer the points are around the form. Like it fits the form better. That's what you're saying. Like it's stronger. It's a better relationship because it's better described by the parabola or the line. So just remember that this one we see in this example right here, I think is where people get confused. This is still a moderately strong relationship because of how close it is around the kind of parabolic form. It might make a parabola. It's just not linear. So good stuff right there. Is someone working on a specific question? We got the same one again here. Oh my gosh, those two are very strong. So which ones show no association? None of the scatter plots. Which scatter plot shows a negative association? One. It's the only one. Which ones show linear? 1 and 2 are linear. Which ones show a moderately, or this is going to be this one's moderate. And which ones show very strong? 1 and 2. Did we do it? We got it. Woo! Can we do true false? Of course, of course. Thank you, Emily, for asking for, is it this one right here? I appreciate when people say, hey, can we do this question? Because I'm sure a lot of people are working on it, and then we get to work on the one you're working on, and we get to answer the questions. So with this one right here, let's look at the questions. A correlation of negative 0.98 indicates a strong negative association. So how do we know the sign of a correlation? How do we know the sign of a correlation? Oh, you got that page. You got it. We'll do that one next. That's a tough one. That one's a tough one because it does univariate and bivariate. That's a really good one right there. So how do we know the sign of a correlation, which is the direction? The sign of the correlation is the direction. So this 100% is negative. And when is something strong? That is subjective, but the closer it is to -1 or +1, the stronger it is. Let's go over to Wikipedia real quick, our favorite way to learn statistics. And they've got an amazing graphic on this. Wikipedia correlation. It's like in my search menu. There it is. Boom. So thank you, Wikipedia. Best place to learn statistics. You can see right here the numeric values of correlation going from 1 to -1. And this line right here shows you it doesn't matter the slope. The slope of the line does not matter. Exactly as Emily says, closer to 1. Good morning, Maddie. Good to see you here. So this right here has the same strength as this one. Doesn't matter about the slope. It's just how tight they are around the form. Why does this have 0 right here? I mean, that shows some sort of like sinusoidal, like kind of a wavy S-shaped relationship. That's what sinusoidal means. Why does that have correlation of 0? Because correlation only measures linear strength. That's a big note we need to always remember. Then whenever we're talking about R, which is correlation, it only measures linear strength. This is Pearson correlation. So in 320, I'll remind you that we go to MyPearson. I just did that yesterday for my students, and I'll be doing it again today. We go to MyPearson, and that's why we talk about Pearson correlation. Yep, nonlinear. Exactly, Paige. Great job. Let's throw some more 20 points to the chat. Thank you so much, everybody, for all the answers, even when I'm saying them to practice them, because when you have to write down an answer, it helps your memory a lot more to remember it than me just saying it. It's one thing to hear me say it. It's another thing to write it down, to practice it, to type it out and be like, that's a nonlinear. And your brain will, when you get to test, be like, wait, if it's nonlinear, then it might have R equal to 0 just because it's nonlinear. I think this is true. Someone correct me if I'm wrong. So we're doing Elijah's house. Are we going over? Yep, we can do some quiz 7. You bet. And then we'll see 320s questions. We got a lot of time. We got an hour. We got 70 minutes, 50, 69. Yeah, we've got a lot of time. Multiplying every value by 2 will double the correlation. Let's just think theoretically on this for a moment. Let's say we have this correlation right here. Let's say we have a correlation of 1. And so it says if you multiply every value by 2, you'll double the correlation. What do you think? Is that true or false? Multiplying every value by 2 will double the correlation. And do I have the notes still up? Because, so think about this. If it's true that this would double the correlation, then the correlation would be 2. So that has to be false. Like, it has to be false. Now, another note, I got to get chapter 7 notes or chapter 6 notes. 2 seconds. I'm going to pull up chapter 6 notes. This will actually help us for later questions. There's, oh my gosh, look at all that craziness. If you look at the formula, which we don't use the formula, correlation turns things into z-scores. So you don't need to know this, but this also gives insight into why this won't change it. Correlation is standardized, so if you multiply everything by 2, it doesn't change it. It's like if I double everyone's... Would it change it? No, you're multiplying both the x and the y's, so it shouldn't change it. It should talk about it. It would divide. It would not change the correlation. They don't go into that much detail on it. Correlation deals with z-scores, so it's unitless. So, the next one's going to be interesting. The units of correlation are the same as the units of y. Correlation has no units. That should be it. Boom. Correlation's unitless. Correlation is z-scored, so it's standardized. There's no, like, my correlation is this much height. It's the variation in y and the variation in x kind of compared to each other in z-scores. And the formula gives some insight on that. We do not solve the formula in the class, but if you look at it as z-scores, z-scores are unitless. So since you're dealing with z-scores that are, you're welcome, Emily, great work right there. And that's just maybe, I don't know, sometimes there's a test question that maybe mentions that. We don't try to do as much theory on the test, but z-scores are unitless, so correlation's unitless, and that's kind of where the answer comes from for that. It's just, the unit square, That's a tricky one. And the percentages one, think about this, the percentages one would not make sense. I can't speak today. Because we have negative, so you can't have negative percent. So it wouldn't make sense. But r squared is a percentage. So when we do r squared again, you'll see that is done as a percentage. And we do that in chapter 7. Let's do the super tricky one. Here we go. This one's tough. So a ceramics factory can fire 8 batches of pottery a day. In order to understand pieces breaking, the factory records the number of broken pieces each day for 3 days. And the scatter plot is shown to the right. Now, we have to make sense of this. They are looking at the number of broken pieces here, and they're looking at them by batch. So let's go right here and trace to the right. If you trace to the right here, we get right here to batch number 1. And it looks like they did this multiple days. Batch number 1, so there we go. Batch number 1 is right here. And batch number 1 had how many broken pieces in it? How many broken pieces were in batch number 1 right here? Just this one I'm over, like this is batch number 1 right here. And it's so, they're doing, I know what they're doing, yeah. This would have this point right here. This batch number 1 right here, this is batch number 1, had, and they're using a point jitter. That's why this is off of this right here. Batch number 1 had 0. Yes, Kayla, does that make sense? You're just tracing the left. Batch number 1 had 0. This is also a batch number 1. They're using what's called a point jitter because you wouldn't be able to see the point if it was overlapping. And it doesn't make sense to have a batch 1.25. But this is a point jitter, it looks like right here, because so the points don't overlap there. Lauren's seeing it too. So this batch number 1 also had how many broken pieces? So this is a batch number 1 had how many broken pieces? This batch right here had how many broken pieces? I'm kind of giving away the answer right here. This batch right here, which is also a batch 1, they're using a point jitter because if you had points around top of each other, you wouldn't see them. 0 also, exactly. This batch 2 had how many broken pieces? This batch 2 had how many broken pieces? Don't worry, I'm not trying to trick anybody. This batch 2 right here had how many 0 broken pieces. Does that make sense? How many batches had 0 broken pieces? And we'll see why we're talking about this in a moment here. How many batches had 0 broken pieces? How many batches, and we don't have to worry about the batch number really on this yet. How many batches had 0 broken pieces? How many batches had 0 broken pieces? So how many batches had 0 broken pieces? 3 batches. How many batches had 1 broken piece? I'm pausing for a moment looking. How many batches had 1 broken piece? Because you're looking at just this variable right here. So 3 batches had 0 broken pieces. How many batches had 1 broken piece? How many batches had 1 broken piece? 8. Nice job, Lauren. Nice job. You're getting this. You're just counting these and you're just basically moving them over. And kind of what you're doing right here, I'll show it visually. might help make sense of it. You're just looking at the one variable, you're just looking at broken pieces, and you're pretty much just making this into like a histogram right here. Like if you were to collect these up into, is that 8? That's 8 right there. And then this is 1, 2, 3, 4, 5. And that's 1, 2, 3. And that's 2. And that's 2. And that's 1. So I'm just dropping these down and having them go into the bins they're associated with. So does this make sense how I just took these points? Let's highlight them right here and show. I'm just taking these points right here and filling up the bin to kind of make a drawing of what's going to look like. If those 3 points are going right there, those 2 points are going right there, those 2 points are going right there. I'm just dropping them down and kind of putting the points into the bin below. So this looks like a unimodal right skew distribution, and I think I see it. Does anyone see a distribution that kind of looks like that on the screen? We got a really good problem today because take a look right over there. You see this exact shape. If I were to turn this, you would see the same thing. So, we can show this because here we'll go to copy. We'll just bring it over to Word real quick. And what? Let's drop this in and we'll go like this. And then we will go to picture. We will go to rotate and there we go. So if you look at this graphic right here, you should see the same graphic right over there. And we just kind of drop those down. So this graphic is this graphic here, and usually they're different enough. Like the only one you might be choosing between is this one. But if you notice right here, this has up to 8. Like that's the 8 dots we saw right there. So we've chosen this graphic right here. So we've got that decided. And describe the shape of the histogram. Is this right to the high or left to the low? What way does that tail go? Right to the high, left to the low, what way does that tail go? I think that's the only one you could make a mistake on here. Is that right to the high, left to the low? What way does that tail go? So right to the high, left to the low. If you're wondering, just in case, sometimes people say, what are you talking about, Brian? I'm talking about you draw your monster, dude. Always got to draw your monster man, dude. So here's the monster man. And then there is the monster man's tail right there. Skewed to the right, right to the high. So you just kind of figure out where the mode is, draw your monster man, and it is right to the high. What feature is more apparent in the histogram than scatter plot? So histograms are going to show shape, center, spread, so we can see the shape of it. So scatter plots show strength, direction, form, and unusual features. Write this down just to review. Nice job, Katie and Lauren right there. So remember, histograms are shape, center, spread. The shape of this is unimodal, right skewed, no outliers. That means the center is the median and the IQR is the spread. Now, the scatter plot is going to show strength, direction, form, and unusual features. The strength here is pretty strong because it's pretty tight around the moderately linear form. There's a little bit of non-linearity, and the direction is positive, but there is some non-linearity to it. There's a little bit of a bend. And there's really no unusual features. So strength, direction, form, unusual features. Good review of multiple topics right here. What feature is most apparent in the scatter plot? It's going to show the skew. And what aspect is more apparent in the scatter plot? There's definitely a positive, somewhat linear. That looks to be correct right here. That looks to be correct. Yes, we got it. What other, I think we've done a lot of these. Let's see. We just did this one. Just did that one. We might be able to finish this all off. Several scatter plots. We've done a lot like these. Which one of these shows no correlation or no relationship? Like the perfect. So in the chat, which one of these shows no relationship? You should see that instantaneously. And which one of these shows basically no relationship, which is going to have a correlation very, very close to 0? Which of these shows like the true no association, pure randomness? We talked about this earlier. C, you're 100% right, Lauren. Great work. Where did I draw C? There's C right there. This shows basically no correlation. Lauren, thank you so much. All these answers. We're throwing another 20 points to the chat right here. And Miranda, thank you so much. Sometimes I do off stars and no one answers questions. I'm like, I'm sad. Let's play the happy sad music. This is the happy sad music. Just because it's nice. Let's do the negative one right here. So A is going to be the most negative and strongest. B, D. That's positive. Strong, and B is negative and weak, or moderate. We got it. And now let's go to question 6. This one right here is tricky. This one also goes off of theoretical understanding. I'll vanish away for a moment. A particularly powerful hurricane has winds that exceed 120 miles from its center. The hurricane was a big storm. Cool. And that affects how we think about the prediction errors. Suppose we add 120 miles to each error to get an idea of how far from the predicted track we will find the damaging winds. Explain what would happen to the correlation between prediction error and year and why. So once again, this goes to a theory question, our least favorite questions. And so z-scores are how we do correlation. So I want you to tell me this. People probably understand height is correlated with weight. With height being correlated with weight, would it change the correlation if everyone in the world automatically grew 1 foot taller right now? Would the correlation between height and weight change? Like, would it be a stronger correlation or a weaker correlation? Would it change if everyone in the world just grew 1 foot right now? Would the relationship stay the same between your height and your weight? Like, everyone's height is going to grow 1 foot. Everyone just randomly goes, what happened? You're just like, oh my gosh. It would not change it at all exactly, because it would still be the same standardized metric, because it's like everyone made a 50 on the test. And would it change the correlation between how long you study and your grade if the professor adds 20 points to everyone's grade? No, the people who studied more would still have higher grades. And it would exactly, and it would not change the way the two variables, like Kale's pointing out, it would not change the way the two variables are correlated. You're still going to have the people who were taller and weighed more still be taller and weighed more. They're just going to weigh 1 foot more. So this adjustment right here, the correlation coefficient would not change, and the magnitude of the correlation would not change, because the z-scores upon which the correlation is based upon would not change. So correlation is based on z-scores, and adding a constant to values, like we can show it right here. I hope this is a big theory question, which we don't usually do that big of theory questions on the test. If we go here to study, and we go here to score, and then we go here to score 2. So let's do a very small data set, and this is how to do correlation, which is a good thing. So we got people studying up to 5 hours, and we'll put here 70, 72, 74, 80, 88. I didn't want a perfect correlation. It's going to be a little nonlinear. 80, 82, 84. Let's see if the theory works. So we've added a constant here now. Score 2 is I've curved the test by 10 points. And let's go here to analyze. Multivariate method, multivariate. Let's just do a correlation on all of them. Let me slow it down so everyone can see. Analyze. Multivariate methods. Multivariate. That's where you go to do correlation. You must use quantitative y variables. I'm holding shift so I can select all of them. And then I'm just going to click the Y button right here. And then let's look at the correlation. And what do we see? The same correlation. You can even see it looks identical when you look at the correlation between score and score 2, which score 2 has had the constant add to it. So we've just shown mathematically here that if you were to have a second variable that is just a constant added to it, it would not change the correlation. So we could also do the example, let's go score 3. Just for one more example on this, because they also talk about multiplying by a constant. Ooh, look what I did. I changed the variable type. The hard way to change the variable type, if you run into this, the best thing to do is to delete the column. If you've done what I've done, the best thing to do is to delete the column, or you have to do this right here. It's so many clicks. The best thing to do a lot of times is just to delete the column. You want to get it back to blue. I highly suggest just deleting your column. It's more clicks than it's worth to fix that error right there. And I can see how someone will be like, wait, where do you click? It's a lot more clicks than even I like to do. I oftentimes just delete the column and start over. And so let's go here back to multivariate method, multivariate. Select all of our variables, drop them in, and there you go. What do you notice right here? Same correlation across. So this is the original score. This is the score plus 10. This is the score times 2. And we get the same correlation because it's turning it into z-scores. And these plots show the correlation right here. Also, you get to see a correlation matrix, which we use in 320 and 201. So understanding that you would trace across to get the correlation between study and score. And look at this. Score, all the scores are 100% correlated because they're all the same data. When they're turned into z-scores, they're all the same. So yeah, That right there shows us mathematically that this answer is correct. What other questions are there? Well, I guess we can do a few more of these. We're almost done on this. So we could finish this off. What do you notice about this one? This one should be pretty quick. I understand that it's a little tricky, but we're doing a car model, and let's see here. An organization that tracks crime statistics reports that car models makes of yada 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 are the cars most frequently reported, while cars of yada yada yada. So is it reasonable to say that there's a correlation? So this is really good for 320 and 201. Can we say that these two variables are correlated, yes or no? And don't worry too much about their answers. I just want you to think about, we've got car model and we're trying to correlate it with car model. So what's wrong with car model and car model? The answer's on here somewhere, but I think it's best if you just see this and you're like, oh, they're trying to correlate car model with car model? And car models like Nissan, they obviously didn't want to label cars right here. My person was like, yeah, we're not mentioning cars. So what's wrong with trying to correlate car model and car model? What is wrong with trying to correlate car model and car model? Why can't we do can we do a correlation with car model and car model? QQ straight enough. No outliers. Why can we do a correlation of car model and car model? Maybe we can. Maybe I'm wrong. It's categorical, exactly, Kayla. So what would you get if you did car model and car model? What would you get? So we should know instantaneously what we would get right here. Oh, and we got our answers on the screen. Please copy this down if you don't have it. But here's the answer for what you would get. The answer is on the screen, trace categorical and categorical. It's not quantitative, exactly, Katie. So take a look at the screen right now and just think about what would you get? What would be your best graphic for car model, car model? They're both categorical. So just practicing and understanding where these graphics are is pretty important. What would you get with car model, car model? The answer is mosaic plot. If you look, here's where categorical trace is down this way. Here's where categorical trace is this way. You'd get mosaic plot and contingency table. So those are going to be your graphics that you would use to do this. So it would look something like, if you just did two car models, let's say, it might look something like this right here. So this would be a categorical display, and it is definitely not a scatter plot, which means we cannot do correlation. And no, since the type of variable is a person, I think that's right. Yeah, that'd be right? Whew, thought I looked at the wrong answer right there. So really important right there. And I think that's basically it. I had something else I wanted to say. We can say that maybe it's associated. So correlations are a specific type of association. Correlations are a specific type of association. So you can say that two things are associated. We talk about that a lot in 320. And I think someone asked that via email recently. They said, what's the difference between an association and a correlation? Correlation is only for quantitative relationships. And association is whenever knowing one variable tells you something about another. So a correlation is a specific type of association. So it's kind of like this. I think it's best when I draw these things out sometimes. Associations are for any sort of XY relationship. Associations is the global, but then if you get down to correlation, it's a subtype within, and it's only for two quantitative variables. So all correlations are associations. So, but only when you have two quantitative variables can things be correlated. So you can't say something is correlated unless you're talking about two quantitative variables. And you would say that they're associated too. Like a correlation is an association, but not all associations are correlations. Just like maybe like all people are humans, but not like if you go down here to males or something, if I knew how to spell males. So just like that. Does that make sense right there? Reverse it, Miranda. You're going to see my crazy points here in a second. Oh, let's see. What level am I at? There's how to do it right there, Miranda. So all males are humans, but not all humans are males. All correlations are associations, but not all associations are correlation. I hope that makes sense right there of understanding when we talk about an association versus a correlation. What am I at? I'm at Brian tier. That makes sense for who I am. That makes sense. I'm at Brian tier. No worries, Miranda. Great job. Wow. Oh, I saw my points. I thought they were your points. I was like, holy mackerel. So this one right here, if you look at it, great job. Nice. Hall of Fame right there. Love it. This one. Oh, I might need some help, everyone. If you've done this one, give me some hints. I mean, I can tell you about it. That's the thing, is I can tell you about how it looks. It's got like a decent, it's got a weakish relationship. There looks to be a changing in strength. It's linear, so I'm gonna say it's probably appropriate. So let's take a look. Let's draw around it real quick. This is how I was trained to do stuff. Is you take it and you go around it, and then you put your line through it. And so it's like a weak, moderate, or weak linear. I don't. Does it have non-linearity? I think it's linear. What's it gonna say? Okay, let's look. Let's figure out if they're wrong. There is a very weak or possibly no association between the two variables. There's a moderately weak negative curved association. Oh wait, negative. This one's wrong. It's not negative. It's positive. Okay, that's wrong. There's a fairly strong. That's wrong. There is a weak negative. Negative. That's wrong. There is a moderately weak positive straight association between the two variables. There's a very weak or no association between the two variables. I'm going with A. It's A. Oh, man. If this had just said weak, I'd have been more confident. Yeah, you are correct. Nice job. Nice, Lauren. Let's throw some 50 points. Lauren, you were correct. It is the very weak. I was between those two. Process of elimination right there brought it down to those two. Yeah, it's like, you know what I want to do? I want to go over here to this, and I want to go and do the following. I want to like recreate the plot really quickly. Let me go right here. And how good is my artwork? I disagree with them. Does my plot look somewhat like theirs? I drew out as best I could theirs, and it's saying the correlation is 0.34. So I disagree. I disagree, my Pearson. Email me if you get this one wrong. I drew it out as best I did. Got a question. Why are deliveries from a ship called cargo, but deliveries from a car also? That's a really good question, Andrew. That's a really good. Why does my Pearson say that this is very weak when I'm getting a correlation of 0.34, and I did my best to draw this out? I did not look at the correlation before I did this, and I would say that that looks a lot like this. There will be more office hours today. What time do we have them today? We have them at. We could do chapter 7 later today if you want. I always like to finish off 7. Thank you so much, everybody. Let me go grab when office hours are. Gotta go to onlineutk.edu. We'll have class here in a little bit. We're going to do 201 class. I disagree, my Pearson. I say that this is a moderately weak correlation. Here's when office hours are tomorrow. I mean, today. We'll be back here from 3 to 4:30. So your time, 3 to 4:30. And so we'll have much longer office hours later today. And we can finish this off right here. You bet, Miranda, you bet. I'm really, but does everyone tell you resemblance? I've been getting that lately. I get different things with my hair length. So it's pretty funny right there. That's, let me see here. What does Spencer look like for iCarly? So I sometimes I get the guy who does a Critical Role. I've been hearing the Critical Role guy lately. Where's he? Critical Role. The Critical Role guy. He's been. There he is right there. So I don't know his name, but I've been hearing. I started to hear him for a little bit, and now I'm getting the iCarly guy. I go through transformations. I think it's just we both have the same-ish hair. So there's the guy from Critical Role, and I've heard him a good bit lately. And so, yeah, Are you serious right there? Jerry Trainer. Is that the guy's name, Jerry Trainer, right there? Or which I don't know. Let me go find that. Okay, let's finish this off. Now I have to know. I have to know these things. Let me look up. I have to know these things. Okay. Okay. Wait, did he cut his hair? What? He looks like Jerry O'Connell. See, I remember back in the day Jerry O'Connell sliders, but his hair is his hair is way longer now. I mean, way shorter now. He cut his hair. Jerry O'Connell on Sliders. Sliders was such a good show. Probably no one remembers that show but me. 90s kid right here. Let's get serious here. That was one of her. Oh, cool. Yeah, it sounds like I know everyone's iCarly. That's oh man, I'm too old. So I'm running into an issue when I run associated function for a categorical lesson quantity. Snail, what issues are you having? Is it saying the let's look at that real quickly right here. I bet you're running into the issue. Is it coming up with the is it saying the chi-squared approximation, chi-squared approximation, chi-squared approximation? Is it giving like 1,000 chi-squared approximation errors? Oh, Kayla, yeah, Sliders was awesome. I love that show. If you're getting the chi-squared approximation issue, put your associate function inside of here. The zero I get, okay, let's take a look. Or you might have to do something. I bet I might know the other one. You might have to add this right here. I was just saying it's just got put on Netflix. Wait, what just got put on Netflix, Mandy? Maddie, sorry. You might have to do, these are the two things right here. Oh, the first two seasons. My gosh, I can't read today. So you might have to do this right here. I'll probably send out an announcement. So in good working on it early. Sometimes you can hit these issues. iCarly. So you might have to go here and do the following. You might have to do plot equals false if it's not printing out the plots. This plot in the background is crazy right here. Does that help right there? If you had the plot equals false argument, and what I mean right here with this top one is sometimes you have to put this inside of here to suppress warnings. But obviously you're not going to just do plot equals false. You're going to do the full XY. But if we put plot equals false, we don't have the plots in our report. So what should we do then? Great question right there. We should go here and we should do a QQ plot of the Y variable of interest. And that'll help determine, which I do think, and we do, it's work hours, right? Is it hours work? Is it hours at a job? What Y variable is it? I can take a look right here. It's the first one, right? Where's the? I think I was doing yesterday. Hours at a job. It is hours at a job. Cool. This should be enough information right here. I'm not trying to give away answers, but this should be more than enough information. You got it, Paige. You got it, Paige. You got it. You can do it. This'll be enough information right here. This is good enough reasoning. Tell me if a grader takes off for this. This, even though we're looking at it, you can look at the overall level, the overall one too, because there's no way this is going to, like, this gives away the answer for what it is, because when you look at this, this is also 201 relevant, because this is a normal quantile plot or normal probability plot. Why do we have three names for it? QQ plot, normal probability plot, normal quantile plot. So this should give away what it is. You can say 320, you can say your reasoning. I'm just like seeing if someone says like, well, we got this issue right here. Look at that right there. And also you got up there issues. I mean, this is the only thing that's holding stable. So this should be good enough reasoning right here. Yep. Here's the code I'm utilizing to kind of create everything we see. There's QQ plot, looks good. So if your plots are an issue, you can turn off the plots, and then what you have here with the QQ plot, and then suppress warnings. Sometimes it's just different samples create different issues. I think what I was working with doesn't create the issue. I think I have some of the code here from yesterday. Was I doing different code? Here we are. Yeah, there we go. And so I was turning off the warnings yesterday, and so that the plots were giving me issues. So you can go right here, and yeah, we're looking at different things. You can go here to plot. It's false. And then you can also do the QQ plot. So now everything generates. I've given away some big hints on this one. And I've got the, please note that I've got the data set attached. I've got the data set attached. So would we not have any other arguments in the associate function? Oh no, you still need all the other arguments. I'm just showing like with the, does that make sense, Naya? That I'm showing with the, like this is the argument you need to turn off the plots. And then over here, oh my gosh, text is so big now. Over here, I'm showing, which kind of just giving away answers now. Showing the way it looks with everything written in here. So you could technically, I might, I prefer it the other way. Is that all making sense? Hopefully that makes sense right there. Awesome, Miranda, you're welcome. Let's see here. We're gonna try to finish off 320. Thank you so much. 201. Thank you so much, 320, for asking the questions. Because a lot of people, I'm sure, are stuck on those. There's just so many little errors you can run into, so many little things that can happen, and that's just working with data. And you gotta be like, okay, let's work around this. This does the scatter plot indicate that it is appropriate to calculate the correlation? It better not say there's outliers on that. I'm gonna say yes. It shows a linear form with no outliers. These are only minor outliers. We have a really great way in 320 to find if there's outliers. In 320, if you want to look to see if there's outliers between data, so there's such an easy way. The way to know if there's outliers, it's so easy in 320 because we can go here and we can go to an influence plot. And with the influence plot, we can just graph it. And there are outliers. So looking at this in 320, we can tell pretty instantaneously that there are outliers. We've got this point down here, this point down here, and this point up here. And we could see this visually over here in the visualized model. And that's how we do that in 320. And so these are the points that are outliers behind my head right here. So it's really easy to identify those points in either one of these plots. But that's how we can do it in 320. But looking at this graphic right here, I don't know. Does standardizing the variables make the correlation 0? It's my question 6. I'm having trouble understanding it. Standardizing it should do nothing. Good question right there, Lauren. Standardizing should not change the value of correlation because it's based on z-scores. So standardizing it will do nothing to it. And this is strong. Let's see here. Positive linear. There's a strong positive linear association between drop in speed, the greatest. Okay, good. I think so, right? Strong positive. Woo! We got it. Nice job, Maddie, practicing right there. Does not change the correlation when you standardize them. So the last one right here, this is it. We got this. Let's do it. If we assume that the conditions for correlation are met, which of the following is true, briefly explain. A correlation of 0.02 indicates a strong a correlation of 0.02. 0.02 is about the what is correlation. 0.02 is about the what is possible correlation. We've got our Wikipedia graphic up to help us right now. Correlation of 0.02 is close to 0. And if we're talking about linear correlation, then we would see something like this. Oh, no worries, Maddie. You're doing great. I appreciate it. You're right there. You're helping out. Don't worry about being on the delay. I didn't even notice, actually. I thought you were watching live and everything, so you're doing great. So correlation of 0.02 indicates that there is... I wish we could just like talk to it and it would say, okay, that's right. Correlation of 0.02 indicates that there may be no linear association. That's good. So standardizing the values will make the correlation 0. That is very false. Ooh, we're on the one that Lauren's on. Lauren, we'll get 100 on this. Let's do it. Standardizing the values will result in a correlation of either, nope. Standardizing the values will switch the sign, nope. Changing the units of these, will not affect the values of the correlation. Exactly. Exactly true right there. Adding an outlier can dramatically change. What can outliers do? We know this. We know what outliers can do. Outliers can do anything. So adding an outlier can dramatically change correlation. 100% true. That's why we say QQ straight enough. No outliers because outliers can dramatically change correlation. Great job. We got some 320 done today. We got some we got all of 201 chapter 6 done today. I'm gonna drink a little more coffee right here. That's it for coffee. We're out. No more coffee. No more coffee. Let's hop back to space. What music today? What music? I like this music to end. It's just like relaxing. Nice, relaxing music. What questions are there? Any last questions? Great job, everybody. All of Chapter 6 has been done. Hopefully completely explained. Oh no, what error are you running in? Sometimes resetting R will fix that. I don't know why, and I want to actually figure out why. And I'll throw big extra credit if anyone figures out why sometimes the QQ plot throws you an error. You're welcome, Lauren. Glad to help out. And thank you for swinging by, like working on the problems, asking the questions. You can always be like, hey, Brian, like, especially if we're just kind of goofing off like now. I mean, now's the end of office hours. You can be like, I'm stuck on this problem. Oh, did you send it to me via email? No, you sent it in the chat, right, Andrew? Send it to me via email because I think I may have lost it. So I didn't click on it during class because if I click on things like during class, then like I can play this on YouTube. There's things I can't play because I could get copyright striked. So send it to me via email and I'll definitely check it out. I've definitely seen ooh, a bunch of times. That's real awesome. Oh no! What error is it, Snea? What error is it? I don't like the solution for the associated error. Why is not working is only with certain variables. There might. So what it is? Let's examine that really briefly right here. It's one of the plots. There's Critical Role, dude. His name is Critical. Oh, you couldn't see it. Let's go back to the main screen. Send on Discord. I like it. We still got a minute 30 on this song. Okay, let's go back to the main screen. Let's figure out. Let's solve it right here. I'll send it on Discord. Awesome. So it looks like maybe can you put your full code in here? Put the full code you're running because it sounds like you're using. If resetting doesn't work, it sounds like you're maybe doing it on your categorical variable. Because QQ plots are only for quantitative variables. So if you try to do it on a categorical variable, here we'll try doing it on a categorical here. So it gives this error when you do it on a categorical. So it looks like the error that when you reset R, it fixes that issue. I've had it give that error and then I've reset R and it works. It's like, let's see right here. So we're going to try to get the associate, and I might send out an email if we can get this to work. It's one of the plots has an issue, and I think it's like it's not coming up with information for that plot. Maybe I'll update the function. Okay. So this plot here on the bottom right is broken. It doesn't have the information to make that plot. So you know what we're going to actually have to do? We're going to actually have to turn off that plot. Let's turn off the plot. Okay. So here is Dr. Petrie's associate function. This is the associate function Dr. Petrie created. Really? Okay, let's go here. What? Come on, let me grab the associate function. We need more music. I like the piano music. Okay, so what? Okay, let's do it this way. Go. This is the associate function. This is what runs in the background. Okay. Let's call it Brian associate. And let's drop it in right there. 1,000 lines of code. Let's remove the stuff we don't need at the end. 1,000 lines of code. We gotta find what we need right here. So let's run it to see if it runs. And let's go grab this right here. Okay, it's saving the associate function in. Yeah, it's definitely the histogram. And so we're gonna remove out that part of it. So what we're gonna do now is we're gonna see if Brian associate works over here. So we've just taken his function. Okay, it looks like it's running the same, which is good. It's gonna crash on this still. So it's still crashing on this histogram over here on the far right. So let's find where the histogram, we know what function does hist. And there it is. So how many hists are there? Okay, that is... This looks like we're getting close to it. That's when you're in Spearman, so that's a category, quantitative. This might be it. Or might be close to the right one. I feel like we're getting close to it. Top left, wait. These are the permutations, okay. There we go. This is we need another song here. I think we can get it by the next song. So this histogram right here, chance of value discrepancy. We're in the right stuff. We should have just Googled this. Did you make 3 of these? How many? One. Let's start at the beginning. 1, 2, 3. Boom. This is the one. Okay, so this is the one that breaks. And can we just comment it out? Let's do it. Let's just take this right here. And let's just comment out the code with a block comment. Let's just see if that runs it. Let's rerun the associate function. We block commented out the code. And now let's rerun this. And the answer is we're getting the error still. All right, let's take a look. Let's find out where that code is. We're close to it, I think. I think we're really close. Here's the one we block commented out. And see, I bet he's repeating this. There's the axis equals false, axis 1. He should set up the grid here for this. The should just be if plot equals true. There we go, if plot equals true. There's if plot equals true, so this is the plotting of it. Do this right here. And this should be the one that's breaking it. Unless he did them in a different order. Dr. Petrie, your code is so confusing. Wait. This is very important we know which. Averages, mean ranks, it's the medians. So it's averages, mean ranks, it's the medians that's breaking. This is the one that's breaking. Oh, you know what we could do? Oh, I got an idea. Better idea. Let's just go right here. Okay, one more song. I think we got this. I got an idea. So my idea is we take right here and we take this and we say broken output. Take that. Ooh, we got this, I think. Really? Okay. Let's grab this right here. Come on. You can... But I did not like it. Oh, it's the permutations are breaking now. Error in his default, perm, median. Wait a minute. How many of these are there? Okay. This is the one that's breaking. It's this one that's breaking. So we don't need the Y lim for it. And it's also making the histogram right here. So Y lim, this is the limit on the Y axis. So let's just say right here the limit on the Y axis is defined. Okay, this is a massive function. I don't want to do that. Function ends right here. 10. There we go. Okay, let's see if we get this now. And the answer is... What is this? 5th tries the charm? Ooh, getting closer. Error in plot window, need finite xlim value. So I think it's the xlim is breaking on now. Xlim, so x limit. It's going to go to 100. Rerun again. And boom. We have it. It is fixed. Okay, I will send this out. This now works. And does that say broken output? There we go. Let's go to where it says broken output. Broken output. And let's go right here where we have, I just made a uniform distribution. Let's listen to one more. Celeste music. And mean ranks, center, mean ranks, center medians, center broken output. Kayla, we've done. I know it took a while to get it to make the histogram, but I said to heck, I'm not going to comment it out. I'm just going to, make it so it works, or make it so it, and now, okay. Yeah, now it just says broken output. So now when you do it, just broken output. That's got it. Oh, that's wrong. I played another song in the background. I'm playing a song. There's my button to return. So I'll send this out. I'll send it out as an update, and I'll say like, hey, run this. What you need to do, and maybe I'll have to update the file, because here's what this is gonna be crazy. Ready? Ugh. What I need to do is this. I'll do it while I'm talking about this right here. I need to take this. Let's call this associate. What should we call this, Kayla? Associate fixed? Associate 2? We made a custom function. And we're going to go here. Let me remove this. 2 seconds. Okay, I don't have a student ID in there. I put fixed student IDs. We need to go here. And we need to insert a chunk. And then what we're going to do is we're going to put the options of show nothing, run code. Okay, so include equals false. This code will run. So the reason is I think it's unable to do the permutations. So the histogram just has nothing in it. So the histogram has no data. Does that make sense? So since the histogram has no data, we could probably try to replicate that by doing something like x store into x a null object, and then go hist of x, and there we go. We get a similar error. I think it's just that there's not the data for it to do it. So since there's no data for it to do it, I believe that's the error it's running into, is the way the data just is not properly formatted, and it can't do the medians test, which I should talk to Dr. Petrie about this and say, hey, there's sometimes a problem with that medians test. Turning off the plots work, because then it doesn't do it. But yeah, I'll probably try to look into more why it's happening, because we basically did like the band-aid over it. So we got it to work, but not the way one would probably want to get it to work if you're gonna like it works for now, which is good. There we go. So yeah, I guess it's a really good question why it's breaking. Like, I'm gonna do more investigation. Like, the band-aid solution works for now. But for now, if I run this chunk right here, does everyone... Ooh, it opened it up. Close back up. You could probably run this chunk, which is a ridiculous chunk to run. You could run this chunk by running all chunks above. So, and it's going to probably get mad about student ID, because I've got just no number in here. I've got, this. So I'm just going to put in 555555, just fake student ID. I'm going to run all chunks above right here. This will create a random sample using 55 as the last numbers. And then if we go down here, we should see better success. Let's go down to this task. Oh, we're good. We got 30 minutes. And so much writing. Brian, why'd you write so much? Task 1. Here we go. Associate. Okay. So associate function. Associate 2 stored in the global environment. Do we want to... Nice. No, don't worry, Alexander. We're just talking over some 320. Associate 2 function. So X21, hours at a job. XO, gender. And do data equals my sample. Seed equals, because we've got to set a seed. There we go. And run it. And we have it. And we have broken output. So that's got it. And we did all the custom stuff right here. I'll probably send out... Nice. Is it making more sense, Kayla, as you look at this and you kind of review how it works? It's kind of what I got. What's up, Jacob? Good to see you here. So we just got our broken output on the bottom right. I might email Dr. Petrie later and just say, we're into this issue. I stuck a Band-Aid over it. I didn't see anything about what... always use seed, yeah. And so we always use seed for replication purposes. Yeah. And so thank you for everyone for starting early, because it's just, you never know what issues you're going to see. And then the reason I'll do stuff like this is I wouldn't expect you to go in and recode the function. Like, I searched through 1,000 lines of code, Control F or Command F is your friend to find what you're looking for. And then I know, I'm able to read the code and understand the arguments, but I probably couldn't do that 3-4 years ago. Yeah, 2021 works. Truthfully, the seed doesn't, I think I said current year seed in the assignment, like use current year as the seed. Seed reminder, at all points when randomness involves, set a seed to control the randomness so your results will be replicated. 2021 works. It's current year, so. But as long as you're using a seed, you're fine. Good job right there, Alexander, on the points. But yeah, as long as you're using, and then you can look at all this. You want to close this off, though, so you can close this off so it's not kind of taking up so much space. And then you're on line 1,000. Congratulations, you now have 1,000+ lines of code that you've gone through. I heard someone say that they had 1 million lines of code. And I was like, I don't know about that. I don't know if you got 1 million lines of code. I mean, I guess some programs have 1 million lines of code, but not the ones we deal with. It wasn't anyone in our class. One more song here, then we'll end off. Classic ending song. Any last questions? We'll post this. So I'll post this later. Let me just hit save on it right now. I think it's, yeah. Oh, let me put student ID back in here. Am I hallucinating? I thought I put in a student ID. Wait, I put data 555. Oh, no. Wow, how did this run? Data 555. Yeah, I'll send an update. I'll need to tell Terry and everyone else, like, I updated it and included a function that won't have issues. Make sure this is closed. I might even make a short video or at least point to this and say, check this out, I updated it, so that way that output doesn't break on you right there. But I'll send an update. And thank you for starting early. Sometimes you hit these like random things right here, but if this was like a capstone class, I would have you deal with it. Because if I can solve this in 10-15 minutes, then I would expect that, like this would be something more difficult to solve. But 320, I don't want you trying to do this in 320. I don't expect you to do it. And like I keep saying, years ago, like a few years back, I would have a harder time dealing with this, but now I just look at it and I'm like, okay, that says this says this. It becomes a lot more easy to read, like making a list right here is items in a list and defining the things for each list. So that's a null object. Yeah. But great job, everybody. I think that does it for today. I will see classes later and see people in office hours later. But as we like to say, bye for now, everyone. Bye. Jason, we just need the wrong button. Wrong button.